All right. So I will share my screen and then we can get started. Little bit about myself, guys. So my name is Surendra Chaudhary, and I have been working in IT industry for last 18 years. Okay, and I have done BTech from MBM Jodhpur, and I have also done one executive course from IM Calcutta. Other than that, yeah, I mean, I have been working on the data science for last 6, 7 years, and on GenAI for the last 2 years. Okay, so that is a quick introduction. Let me. Okay. So a little bit on the course introduction. See, this course is basically to teach you guys how we can create some large language model based applications. As you can see, in the last 2, 3 years, we are hearing a lot about this generative AI and using generative AI to accomplish a lot of tasks. So in this course, what we will be doing is we will build our strong foundation on these large language models. We will study how they are trained, what are large language models, how they are trained, and how we can use their APIs to create some applications which will be based on these LLM models. So we will be creating some chatbots, some intelligent assistants, some agents as well. Okay, and we will also study about the LangChain, which is one of the most famous framework uh, for this, GenAI. So what that does is it basically help developers to create LLM-based applications easily and in a very fast manner. So we will deep dive into LangChain concepts. Okay, what is a LangChain? How to use it to create such applications. LangChain also comes with another module which is called as a LangSmith. So LangSmith help us to monitor our application. So when we build our application, any LLM application, we also need to monitor it, right? What is going under the hood, whether it is able to call the LLM or not, right? So in order to get insights, what is going inside our application, in order to create traces and logging and to monitor, we will be using LangSmith. Okay, so that is also comes from LangChain. So LangChain is a company basically which has, which is not very old one. I think with the boom of Gen AI, I think this company is maybe 2 or 3 year old. Okay, so the competitor of LangChain is Llama Index. That is another startup, which basically serves same purpose. Uh, that is also being used by developers to create LLM applications. Okay, so in this course, we will deep dive, and I have chosen LangChain, and we will go into the depth of the LangChain, and whatever code we will write, whatever applications we will build, that will be based on LangChain. Okay, and all the course modules, all the sessions, whatever we will do, that will have some hands-on session as well. Some exercise will be there, so we will do those exercises. Some exercises will be given as your homework. Okay, so you have to take all those things very serious. If you really want to learn, you have to, make your hands dirty. You have to code sometimes. You have to do it. You have to complete your exercises. Then only you will be able to, understand the concepts. Okay, so that's pretty much on. If you want, I can one more time go through the content of this course. We will be having some 12 sessions during the weekends. Okay, so in the first session we will go through the fundamentals of generative AI. We will try to understand the machine learning and AI concepts, and then in the next session I have added this as a new session where I will be, if you are interested, I can run some machine learning models and some deep learning models which will help you to build your understanding saying, what does training a model means, what we should expect when a model is trained with the data, what kind of output is generated, how they are trained. So that will clear your some concepts and some myths about machine learning concepts. I will also try to cover some Python, okay, some basic Python which will be useful in our course, right? Since we will be building some applications, we will also use Streamlit to create the user interface. So in all those aspects, Python is a bit important. Okay, and Python is also one of the most usually language when it comes to the data science. Okay, so it has that capability that most of the people uses Python for all these purpose. So we will look into the basic concepts of Python. Okay, we will in the third session we will see how LLMs are being used as of today in different consumer applications, and we will see how the architecture look likes. Okay, so that you will have some holistic picture. Okay, this is my this is my entire ecosystem, this is my front end, this is my back end, this is where my large language model fits into the entire system. So that I will teach you in the third session. In the fourth and fifth session, I will cover the LangChain, which is the backbone, right? Whatever applications which I have seen in the industry as of today, almost 80-90% of those applications are built using the LangChain concept. So this LangChain has got matured a lot. So now the applications which are going into the production are using the LangChain. So we will deep dive into that, and then in sixth session, what we will do is I will teach you how to configure or how to set up your local system if you want
So,
to do. Yeah.
sorry, Surendra, just one thing. Like on the column E, there you have project one, project two, project three. So these are the kind of exercises that you were talking about, like the homework
Yes.
sort of thing, right?
Yes. Yes.
Okay.
Yes.
Okay. Thanks.
So environmental setup, I will tell you how we can set up VS Code, how we can use Microsoft's Copilot to write our code, how we will be creating virtual environments. Because if we don't do all these things, we will mess up our environment and we will not know what's going wrong. So we will understand and study the right way of setting up the developer's environment so that we don't mess up with the libraries. What happens is, if my project one is having some dependencies, the project two has some other dependencies. If I use the same virtual environment, everything will be installed at one location, right? So if my project one is working, functionality of my, project two will break. To avoid that, what we do is we create separate virtual environments for each of my projects, and I will be installing the libraries into those projects based on my project. Okay. So I will tell you more about that in detail, and then we will study about the Streamlit. So Streamlit is one of the most easiest Python library which we can use to build up our graphical user interface. If you want to show anything to your supervisors, to your managers, to your stakeholders, then as a data scientist or as a Gen AI, consultant, I'm not supposed to create my graphical user interface, right? I may not be proficient enough to build UI in React or some other technology. So what I can do is we can make use of this Streamlit to easily develop some graphical user interface so that we can show our application to the user. Okay, so I will explain you the different components, the different widgets which are there in the Streamlit, with which we can create our UI very easily without, getting the things complicated basically. Okay, so that is on a Streamlit. In the eighth session, I will talk about RAG, which is the most important concept in the generative AI. We have seen that the models, right? So if I talk about chat gpt, what is chat gpt? Chat gpt is a application basically, and in the back end it is using some large language model. Okay, so chat gpt will be able to answer almost all questions regarding the data on which it is trained. Okay, just like a machine model, large language models are also models which are being trained by vast amount of data. But if I ask ChatGPT about any questions about my personal life or maybe my personal documents, for example, my Gmail or anything like that, it will not be able to answer because it is not trained on that data. So, in order to overcome that particular thing, what we do is we implement the concept of retrieval augmented generation. So, what we will do, we will take our own personal data. That personal data can be your company's data or your company's policies, procedures that may be saved in, Amazon or Azure, anywhere. Your private data, your confidential data, which is not available outside, is on which your large language model is not trained on. So if I want to interact with that particular data, what I need to do is I need to implement RAG. Okay, we have to create vector database. We will vectorize our data. We will create embeddings and we will store in the vector database, and we will also plug in LLM. So this concept is called RAG. Okay, so this we will study in our eighth module. In the ninth one, we will talk about some advanced concepts. Okay, in the RAG, whatever my input data is, that may be Word document, that may be PDF document, but the simple RAG will work only with your text data. But what if I have images, some complex data in my PDF files, right? If my input file or my company's data is having lot of tables, right? Let's say some quarter four results of my company, and I want to create some application which can answer me, right, based on that particular table. So that kind of data is a complex data, right? For that, I need to use some advanced techniques so that the text or the data can be extracted from those complex documents. Okay, so I mean, this may be looking a little bit, I may be confusing you guys, but this is the quick introduction. You may not be able to understand 100%, I think. Okay, so we'll talk about all those things, and then we will also create some agents which are basically autonomous applications which can also think, right? When we create simple applications, what will happen? I will ask a question, it will go to my large language model and it will reply me the response. It will give me some response. Then again, I will ask a question and again it will respond, but it has no capability of reasoning. So when I create agents, what I am doing is I am automating this loop. Okay, so my agent will be an autonomous application which will ask some question to the LLM. It will receive some response. It will analyze that response and then decide its action basically. Okay, so we will build some agents. We will again use LangChain framework. There is something called as a Lang graph. Okay, so we will use that framework to build the agents, and then we will go through some advanced concepts. How to do the RAG using the agents, how to make use of the agent memory and things like that. And in the last session, what I will do is I will create an application end to end, and then we will deploy it to some server so that you will come to know how the things are working end to end. Okay, so that will be our final project. So, I mean, it will not wi- it will not be the end. If you think there are couple of more topics which I have not covered, maybe I can add one more session for that, and I can take on, some miscellaneous topics which you think are important. Okay. Any questions on that, everyone?
I have a question.
Yeah.
Um, so in our local system or machine, we will not be installing anything or no work is required, right? It is completely going to be on virtual environments.
No,
Is that correct?
yeah, I mean, when I will be developing applications, what I need to do is I should have the Python environment. Okay, and I should have VS Code. So these are the two things which are required on your local system.
So that means it is required for us also, right? To
Yes, yes, yes,
keep.
yes. Mm.
Python and what else?
VS Code. VS Code is an
VS Code.
IDE.
Okay.
Yeah.
Yeah.
Yeah, but you will have to direct us, right? So can we do that in Mac also?
Yes, yes, definitely. Mac also
Okay,
it
okay.
works. So that's what I said, right? I will be taking this environment setup. Okay. In general, we can write code in Google Colab also, right? But that is something which is not very fruitful because we have not created any GUI. When I need to create graphical interface, right? When I want to give it some application kind of feel, I should be using Streamlit and I should be using VS Code. to write my code, I mean, properly, I should be committing my code to the GitHub and things like that. Since I will be showing my projects to some stakeholder, right? So that's why it's better to have VS Code setup on your machine and Python installed, so that we can build our applications and we can give demo to someone.
So a specific configuration for the machine required,
No,
or
no,
like.
no, no, nothing,
Mhm.
nothing. 8 GB RAM is just fine, minimum.
Mhm.
I think 16 GB is something which is very normal these days, but even 8 GB is fine. No specific requirement. Okay, but
Thank
yes,
you. That
if you
that saves some expenses.
yeah, but if you want to install some models on your local machine also, right? What most of the time, what I mean, we will do is we will use APIs to connect to our large language models which are hosted somewhere else. It will be just an API call. But if you want to deploy the model on your machine itself, that can also be done actually. So that will need some good configuration, like 16 GB, right? On my laptop, which is, I mean, ThinkPad, I can deploy models and I can run the models locally. Okay. So if you want to do that, I mean, you need little bit of laptop capability, good RAM and good configuration. But it's not a showstopper. Okay. It's just an additional thing if you want to do. Okay. Anything else, guys? Feel free to ask. Okay.
I have one question.
Mm-hmm.
Are are there any data science related topics here?
Data science related topics are not there. I will just cover some basics of machine learning and AI, and that's it, right?
Okay.
Because data science is a very vast, I mean, area, right?
Okay.
How if you create the data pipeline, you have to clean the data, you have to use lot of uh, lib I mean libraries to clean the data,
Mhm.
right? And then you will be analyzing your data. You have to use some libraries like uh, Plotly, okay, to visualize your data, and then you train your
Okay.
model. So that's a altogether different stream. But we are mainly focused on generative AI, how to build applications using large language models, which are very strong. Okay,
Okay.
I will tell you why these LLMs are so famous. I mean today itself, right? Why there is so much of boom in the last 2 3 years. I mean, definitely you all must be knowing it, but still, you will cover that.
Okay.
Yeah,
And
absolutely.
about the code setup, can we use Python, or
Ye-
only like we'll be working on Visual Studio Code only?
I mean, you can use anything. That's just an IDE, but I will be using VS Code because that's how most of the, I mean, projects and developers are being, I mean, using in the industry. So that's an industry practice. But feel free to use anything if you are comfortable with something else.
Okay.
Okay. Whatever projects I have done in my company, we have been doing it on the VS Code because it has lot of different modules, and GitHub Copilot can also be integrated with that, so that will help you.
VS, yeah, VS Code is this thing, right? Your JetBrains ID.
Let me show you just a second.
And I have one question. Is there
Yeah,
any
okay.
specific foundation model you will explain? Like Anthropic, Tychan, any?
No, so we will be using OpenAI models, and we will also use Llama models mostly.
Okay, like in the AWS, we have Bedrock. That concept you will not cover here, right?
I mean, if you want a little bit of overview about that, I can cover in my last session. Because see, these are the basic concepts which will be applicable to Azure and Bedrock and all these services. So all these services are also doing same thing. If you know what is embedding, how to create embedding, so they
Yeah.
they, they
The
are just
concept wise is the
platforms.
same. Yes.
Yeah, I mean they are just platforms which are automating all these things.
Surinder, in that case, if we are using OpenAI, then for OpenAI, we are frequently getting error that rate limit error and insufficient quota. Then how we can mitigate that error?
So
If we
yeah, I mean what see there are two options. We will use the Grok API first of all. That
okay,
Grok API is 100% free. Even you don't need to add your card details. Okay.
Okay.
And what it will do is it will help us to invoke the open source models like Llama models. Okay. In order to give you, some exposure how these OpenAI models work, that you need to create one account with the OpenAI. Then I think you need to recharge your account with maybe $5. So that will be more than sufficient for you guys. Okay.
Okay.
So let me show you.
Hi. Can you use your office laptop as well?
Yes, you can use.
Because it's high configuration. 16 people.
So what I did was I just recharged it with the $5, and you can see it's very less. Usage. It's just 4.96 is still balance. Okay, but yes, you need to give your card details. If you don't want to do this, then also fine. We will be using, most of the times we will use Grok. So Grok is a platform.
How we can recharge it?
Yeah, you have to add your card details actually.
Okay.
Okay.
In billing. Okay.
Yeah, all these things. I just added my card and then I recharge it with $5. It will not go. It will not be used beyond that. Okay.
Okay. Thank you.
Because OpenAI models are the strongest models. So in order to get the feel of it, I think in one or two lectures we can use OpenAI also. Okay. But most of the time we will be using Grok models, which are totally free of cost.
And it will
Okay.
cost very minimal. It will add like $5. And once
Yeah.
this $5 completed, then it will again
Your
intimate us. Yeah, need to add more money like this one.
yes.
Without our consent, they will not add to from my credit card like this. Correct?
Exactly. So
Okay.
I have not enabled the auto recharge. Okay.
Okay.
When
And
your
what
credit
about
balance.
we are deploying it to Docker image, right?
So that I may show you in the last lecture, right? In the case of deployment. Okay, but most of the time we will be building our applications in this IDE. Okay.
In Gemini, also the same concepts like vector
Mhm.
storage, data chunking, the same
Mm.
concepts
Yeah,
they
yeah,
are
yeah, yeah.
using,
The
right?
concepts are same everywhere, right? Whatever model do you use, whatever platform do you use, the concepts are pretty much same. But the models are different for different platforms. Some emphasis on OpenAI models, some are, you can use Anthropic models or you can use Gemini model, whatever model you want to use. But in industry also, most of the time these OpenAI models are the most famous one, right? So they are being used mostly. This is my experience, at least in my company. Okay. So with that, I think let's get started. Started with our. So this is what we are going to do. Okay. So again, in this particular session, today's session, what we are going to do, we are going to understand how does these large language models work, what is machine learning, what is AI, and I just want to give you some intuition that how these LLMs are trained, what is going in under the hood, how it takes your input, how it process your input, and how it generates the output. Okay, so all these things we will cover today. So a little bit on this introduction to AI and ML. First of all, can anyone tell me what is AI? What is your view on AI? If you need to define artificial intelligence, what will be your reply basically? Anyone, please?
A machine that has gathered intelligence in not in true sense, but more like by learning the behavior, how the user interacts with it. and based on that, it kind of keeps on building its knowledge base to say.
Correct. So when we talk about artificial intelligence, and any machine which can mimic the human behavior, right? The way humans behave or the way humans think about anything, the way human do any task, if that machine is also capable of doing that, then we say that okay, this is artificial intelligence. Okay, so all these things, right? Machine learning, neural networks, deep learning, generative AI, LLMs, all these are nothing but they are part of the artificial intelligence. Okay, sometimes we usually get confused how it is different. Is artificial intelligence part of the machine learning, or machine learning is part of the AI? So this is to give you that picture basically. Any task which a machine can do just like a human being, that is called artificial intelligence. So this is the bigger circle is artificial intelligence, AI. All these are AI only, right? But if you talk about a specific uh, part of it where we actually teach the models with the data, that is called machine learning. We feed lot of data to a model. It learns the patterns which is there in the model, which is there in the data, and then it will be able to answer, right? So that is called machine learning, when the machine learns from the data, from the insights of the data. Okay, neural network is something when we change the way basically of training a model. Neural means the neurons which are there in our brains. So the idea was to the way human beings learn, right, with the help of neurons. These people wanted to build.
Sorry, Surinder, for
Yeah.
actually, are you share your screen?
Yes, I am.
It's not visible to me. That's why.
Is it visible to others?
Yeah, it is visible to me.
It's
Yeah,
visible
it's
to me.
visible. It's visible, yes.
Yeah.
Let me join again, I think.
Okay, let me reshare my screen. Unshare and share.
So, Surrender, while you are doing that, I have a
Mhm.
question. Are you going to build a model also?
No, we are not going to build any model.
Yeah,
But
now it's visible. Thank you.
yeah, but if you want, maybe in the next class, I will build a model, some machine learning model basically, or some deep neural network model for you guys, just to show you what kind of data we have when we train a model. So I will take some sample data, I will train a machine learning model, and then I will show you how it can, uh, do some task. Okay.
So
Okay.
so it's that simple that in a 2-hour class you'll create a model,
Yes,
basic
yes,
model
yes.
basically.
Yeah.
Okay,
It
that's
depends
interesting.
on the data, right? It how much data you have, how much training you want to do. Okay.
So would you also be able to list down some, and probably it might already be a part of the course, but like if I have to practice more or something, then uh, like
Resources.
there's resources for the data, like base data or something.
Yeah. I will share that also. Okay. If you are more interested in the machine learning part, I will tell you how you can learn all those things. Okay. So the idea is, in case of neural networks, the neural networks are inspired from human being, how they think, right? We also have the neurons, millions of neurons we have in our mind, and the information is passed from one neuron to other. Okay, similarly, the people or the scientists have developed these neural networks where we have different layers. I will show you in some time where we have different layers and the model is being trained with the input data. Deep neural network or deep learning is something when we have more number of layers. When we increase those layers to maybe 8 or 10 or 12 or 15, then we start calling neural networks as deep neural networks, DNN. And then generative AI is again, in the back end, the generative AI, when we talk about large language models, these are also neural networks or the artificial neural networks or the deep neural networks, which are being trained on vast amount of language data. And then the capability of these Gen AI models is that they can create some new text which they have not seen in the past. Okay, so when I talk about these neural networks or deep neural networks, what happens is when I teach them, okay, this is image of a cat, if I feed 100 or 1000 of cat pictures, what my neural network will do is it will start recognizing, okay, every cat has 2 ears, 2 eyes, this is how the cat looks like. Okay, so they will learn those patterns. And then if you feed an image of cat and you ask your neural network, is it a cat or a dog, then it will be able to recognize, okay, this is a cat, because it has learned the different features of a cat based on the input data. Okay, but how generative AI is different from all other is that it can generate altogether new image of a cat, right? If we use these models like multimodal models, we can say generate an image of Lord Ganesha or Lord Ram. So what they are doing is they are able to create the images altogether, which they have not seen in the past, on which we have not trained the model explicitly, right? So that's the beauty of Gen AI. It can generate text also, it can generate images also, and it can even create videos also. These days you must be seeing a lot of videos based on Gen AI, which are being created by these models. Okay, so this is, I mean, that is the reason why it has become so famous overnight. Okay, and within Gen AI, as I said, we have large language models which mostly deal with your textual data. Okay, so this is that kind of hierarchy. And there is another way to look at this picture. When I say artificial intelligence, it is the outer circle. There is something called as the natural language processing. So when we talk about NLP, okay, so you will also hear this term very frequently. NLP is the capability of processing the natural language, the language which human beings speak, the English or the Hindi. Okay, not like we are giving any specific instructions in maybe in SQL or something. When we talk about natural language, means our system is able to understand the plain English. Okay, let's say I have to do some sentiment analysis. I have to see about a product which is there on the Flipkart. I need to see whether the people are liking this product or not. So what I will do, whatever feedback or whatever comments they have given, I can take those comments and I can put into my some application. Then it will be able to tell whether the people are liking this product or not, right? What it is doing, it is analyzing the text, the textual comments which are there. So this is an example of NLP, natural language processing, to process the natural language data. Okay, so that is NLP, and this NLP task can be done by, they can be done by machine learning, they can be done by deep learning, and now these are mostly done by generative AI. That's why it's an overlapping circle. Okay, this is basically a task, and these are the technologies or ways to accomplish this. I can create some machine learning model and I can teach it I can give it the various you know the sentiments or the comments on a product. Okay, I have a CSV file which has the feedback from the different customers. I liked the movie, I didn't like the movie, the movie was good, but the end was not good. When I take such textual data and feed it to some machine learning model, what it will do is it will try to understand the pattern, right? I also need to tell whether that sentiment was positive or negative. Okay, initially to train the machine learning, to train the machine basically. Okay, so it will understand, okay, when the feedback is having some words like good movie, fantastic movie, I loved it, so it understand the pattern. Okay, if the feedback is having or the review is having these words, then most probably that's a positive sentiment. So this is how machine learning works. But when we talk about generative AI, the beauty is that the model is trained so much with the vast data that it is just like us. We are not trained to understand these languages, but since childhood we have heard so many sentences that we have generated that capability, that if someone says that the movie was good, we can understand his, I mean, sentiments, right? In the similar fashion, generative AI models are trained so much that they are able to understand the natural language which we speak on our daily basis. Okay, so NLP are the tasks which can be accomplished by ML, deep learning, and these days most of the time they are being done by generative AI. because we need not to do any training. Earlier, I was training my models, I was testing them, and I was deploying them. And there was a team dedicated to do all those things. Now, what I need to do is these OpenAI, these Google companies have trained such a big model which can understand Hindi, English, whatever language you want to tell it, right? So why I should train my own model? I just need to use my APIs and I just need to pass my text.
Surinder, what is major difference in machine learning and deep learning?
Yeah, so the machine learning, what we do is the number of features or the number of inputs are very less actually in case of machine learning. Okay, let's say I want to build a model which can tell me the price of a house. Okay, so my features will be like the location of the house, the number of rooms in the house, the size of the rooms, number of bathrooms and toilets. Do we have hospitals in the vicinity, right? All those factors which can influence the cost of my house, right? So these are called features basically. When these features are very limited, maybe 8, 10, 40, 50, then I will go with the machine learning. But if I need to analyze an image, okay, whether an image is a cat or a dog, then I need to train my, model, right? But if you talk about an image, if the image is 900 into 900 pixel image, and what, see, these models don't understand these images, right? So what we need to do is we need to give them the pixel level details. What is the color of the first pixel, second pixel, third pixel, right? That means if my image is of 900 into 900 pixels, I will have 81,000 attributes. Earlier in my housing problem, there were just 40 or 50 attributes, the cost of my house, the number of rooms, and all those things. So my machine learning model can understand and can deal with that, but it cannot understand or it cannot process or learn images because of these limitations. For that, we need to do the deep learning network. I will just explain you if it is not making sense for you. Okay. So yeah. Again, in I have taken this slide from Microsoft, okay, from Azure training. So what is artificial intelligence? The software that imitates human capabilities. So humans are, able to visualize the things, right? We can see, okay, there is a car, there is a phone, there is a laptop, right? So similarly, if our machines can also see the world, see the images, and can understand, that is one way at looking at that it has now the AI capability. Okay. Similarly, we can hear the audio, right? We can listen each other. If I'm using Siri or Alexa, which can listen my audio, which can listen the voice, that means that is an artificial intelligence, because just like human beings, it is able to listen the audio, to interpret the audio, and to uh, create some output out of it. Okay, that is another example of artificial intelligence, right? So predicting outcomes and recognizing patterns based on some historical data, right? We also do all these things unconsciously, right? If someone asks me what is the price of a house in Delhi as compared to the price of the house in Jaipur or Jodhpur, I will definitely say the houses in Delhi are costly, because somehow I have learned all these things. Similarly, when we feed lot of housing data to the machine, it will be able to learn, okay, the houses with the bigger rooms or with good facilities like hospitals in the neighborhood is definitely costlier than other houses, right? Interpreting the visual inputs, as I said, the autonomous cars, how does they work? They they have a lot of video sensors. They look at the uh, surroundings, right? And they process all those things in the real time, and then they take decision. There is some object in the front of car, I need to push the brakes, right? So this is how in the real time they process the images and the videos, just like human beings, right? When we drive a car, when we see someone in front of the car, we push the brake. Okay. Understanding language and engaging in conversation. These days you can see we can have all these Google assistants, Alexa. They can understand our language. They can engage in conversations just like human beings. Extracting information from sources to gain knowledge. Okay, so all these are when the machines are having such capabilities, then they can definitely, mimic the human behavior. This is called as the artificial intelligence. Okay. As such, I don't think anyone is going to ask you what is AI, but it's good to understand, uh, all these things. And if you talk about the evolution of AI, there is something called as the rule-based AI also, rule-based artificial intelligence. So this is what in 90s, 70s or 90s, 60s, people try to create. This is called symbolic AI or rule-based AI. For example, I need to predict the uh, price of a house. What I can do is I can create lot of rules. I will say if the location is Delhi, then I will give more weightage that the cost will be high. I can create another rule like if the number of room or bedrooms increases, then the price of the house will increase. So earlier, people thought that if we can create so many rules, no thousand of rules or 2000 of rules, then maybe we can achieve the artificial intelligence. So like that, they created some systems, some symbolic AI systems. So what happens in these systems? We basically create some rules, and we also feed some data, and then it comes and it gives us some answer. But then they change the strategy. When we talk about machine learning, what we are doing is we are sending the data and we are also sending the answers, and then it will create the rules by itself. Okay. For example, what I will do is if I need to train a machine model, I will create one CSV file which will have all these data, the the data of different houses, the number of rooms, the square footage, location, and also the price. I am telling the price of these houses explicitly. And when I train a machine learning model, it will understand automatically that, okay, uh, the flat or the house which is there in the Delhi will definitely cost more. Okay, because we have trained it with some data. Okay, and rules it will automatically create by itself. So this is the difference between the earlier symbolic AI and the modern AI. Okay. So these are again the different AI workloads. For example, machine learning, we have the models, and these models basically are able to predict anything based on the data and the stats. The foundation of AI, computer vision, as I said, is the field where these AI systems can look at the images and it can interpret those images. Capabilities of AI to interpret the world visually through cameras, videos, and images. NLP, as I explained, capability within the AI for a computer to interpret written or spoken language, natural language, the language which we speak. Document intelligence, capabilities of AI that deals with primarily managing and processing and using high volumes of data found in forms and document. Okay, so these are specific to Azure. Knowledge mining, and then generative AI, which we are going to deal with. Capabilities within AI that create original content in a variety of formats, including natural language, image, code, and more. Okay, so these are different terms which as a you should know actually, right? You should not be confused if someone is talking about computer vision, what he is talking about. You should have a little bit idea about all these terms. Okay, so what is machine learning? Is it boring, guys, or it's interesting? I know it's a lot of theory I have been teaching.
No, it's good. At least like
Yeah,
getting to know more about the things that we hear on a daily basis. So
exactly.
for me, at least, it's good. My opinion.
Yeah, it's good. It's good.
I just wanted, that every one of you at least know all these terms, because you should not be blank or you should not be confused when someone is talking about machine learning, right? Because although this is not something which we will do in our program or in our course, but at least I thought maybe I should tell you all these things. So what is machine learning? Now let's talk about. So you have seen this circle, right? So we have, this is called machine learning. So how does this work? So what we do is we have some data, or maybe let me try to pull some data. I could not get chance to prepare more on the first lecture because just after Friday we had this session, right? So let me give me 1 second, guys. You cannot minimize Zoom workspace when you're recording the meeting. Okay, I think I can anyway tell you. I hope you can see my screen, guys. I have not unshared it.
No, we are seeing your face right now. So maybe you want to share again.
Okay. Just give me a second. Tu. I'm searching for some data. Okay. Okay, so this is one of the data actually. So this is some machine learning data, the data which we can use to input our machine. So what it is like, it is the town data, it is the tract. I don't know what is, this is longitude, this is latitude, this is Medvi, Cream, Indus, Chas, Knox, RM, age. So this is how actually we have the input data. For example, for our housing problem, what we will have is we will have the city, okay? It will be city, it will be size of room, okay? And then total area, okay? We have a number of bedrooms, things like that. So initially we will have this data in some database or maybe some CSV file on which we will train our system, train our model. So this is called as the training data. Out of this data, there will be one column which will be price of your house. Okay. First of all, we have some attributes. As I said, the area of the house, the number of rooms and all those, these are called attributes, and Y is what I'm trying to predict. This, that will be cost of my house. So when I train a model, I will have some data which has input as well as the output, expected output. Okay. So this X1 is like number of rooms, X2 is area of the rooms, X3 is the some facilities. Okay. So this data is called as the my features on which my cost of the house depends. So initially my data will have both input and output. Okay, guys. So I will take this training data and I will give it to some algorithm. Okay. So there are some algorithm which are already been written. I will take those algorithm and I will feed this data. One row will be fed to my model, second row, third row, fourth row. So what it will do is it will see, okay, for these features, for this area, for this number of rooms, the cost is 50 lakhs. For any other data, the cost is 70 lakhs. So it will try to interpret how this cost is basically varying based on my input data. Okay. So what it will do is it will try to create some pattern. Okay, whenever the area of the house increases, the price also increases. But if we are going away from the main city, the price will again decrease, right? So it will try to make some pattern out of that data. So this is my algorithm. This is my model. It encapsulates the function. It will calculate what is my predicted price. Okay. So when it will see whatever my prediction is there and whatever prediction which is being given here in the data, if there is a difference, that means my model is not accurate enough, right? Are you getting? So what it will do is it will try to find the difference of the actual price of the house and the predicted price of the house, and its aim will be to minimize that. Okay, if it is able to minimize it, that means our model is trained correctly. Now it will be able to predict the price of a house even for a data which it has not seen in the past. So if I give something like x1 dash, x2 dash, and x3 dash, and tell me the price of the house, your model will be able to predict the price of that particular house. Does that make sense how the machine learning works basically? What we are
Can I
doing in
ask
the
a
machine
question
learning?
here?
Yeah, please.
So as per the previous slide, we were supposed to create the rules using the machine learning, right? But here we are directly predicting the price.
Mm-hmm.
So you explained about symbolic AI versus machine learning, right?
Mm-hmm.
So how is it different then?
Yeah, so we are not giving it to any rules, right? We are not saying it that you have to increase the price if the size of the house increases. Rather, with our given data, it will try to create its own rules. It will get trained on this one basically. Okay, it will try to learn from the input data and it will create its own rules basically.
So this is supervised model, right?
Yes, this is supervised model.
And given supervised, we will anyway, whatever we're gonna enter, it's try to go to the minimum, minimize the gap, and then predict the
Exactly,
best out
exactly.
of.
So when it is minimizing the gap, that means at that time it is creating its own rules. What
Correct.
rule will make the predictions accurate, right? It is trying to adjust its weights basically. Okay, in such a way that once the training is done, if we give it some data without the output, it will be able to tell us the cost of the house.
So for
Okay.
example, we separate the data for 10 city, but if you ask for 11th one, it's gonna figure out 11th by looking the 10th, all the 10th data.
Yes.
Yeah.
So this is on what is machine learning. If we talk about the type of machine learnings, we have supervised machine learning, where our input data will have the output also, right? The data is labeled basically. This is the features of a house and this is the price of the house. This is the features of the house, this is the price. Okay. So like that, when we say supervised, yeah.
Whatever you have shown in that previous example, it's like drawing an empirical relation, is if I'm not wrong, right?
Mm-hmm. Definitely.
Empirical relation, like some powers of
Yes,
the
yes,
speech
yes, 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 yes.
and constant with like some.
Yes. It will have some exponent. It will have some power of, right? So whatever function it will eventually create, that may be like x1 square plus 2x2 cube or plus
Yes.
3x, something like that.
Okay. So is it like all the models will be like this only, or only for a specific predicting like price kind of things only it will use like this kind of model?
The way of achieving that final output will be different, right? So how these models approach or reach to the final conclusion, that may be different for different model, for different algorithms basically, right? Some
Okay.
may be looking at the difference or some may be looking at something else also. So they have their own way to perform this action, but the ultimate goal is to find that function only, which will basically minimize our error and which will be able to the which will the curve which will fit into our training data more accurately.
Okay. I
So
mean,
I
for
mean,
all the use cases, this will be the case.
yes.
Okay. Okay. So any type of like image or all those things also it will like do. I
So
mean, debug in this manner only. I'm not like break the problem into this manner only.
yes, so I will tell you. So in even in the supervised, we have two type of problems. Okay, one is the regression problem where the output can be anything like the cost of the house. The cost of the house can be 10 lakhs, 50 lakhs, 50 crores, or any number which is a continuous number, right? So those problems are called regression. Your label is the numeric value. Your final outcome will be the price of the house. That is not a specific thing, right? That can vary uh, to anything, 50, 100, whatever. Okay, but when we talk about the classification, in that case, what we are doing is we are just telling whether the given email or the output is basically already a class defined. Okay, whether the email is a spam or not. So the final outcome is only out of these two, whether the email is a spam or whether it is not a spam. So we have defined the categories. Whatever data we will feed for the classification training, that data will have, these are the emails. For the first email, look at the content, and we will also tell whether it's a spam or not. If it's a spam, we will say it's 0. And if there is an other email that is not a spam, that's a ham, we will say 1, 0, 1, 0, 1, 0, 1 data. Right? So classification means we have the final output as some category. Label is or is not a class. Binary classification means the final output is of 2, yes or no. Multi means we can have multiple categories. If we pass an image of any cloth, it will say whether it's a pant, whether it's a shirt, whether it's a cap, whether it's a shoe, or like that. We can create those classes basically. Image segmentation, for example. Does that make sense?
Can you come just once again on
Yeah.
the pants, like how this is going to make a curve out of this pant image, or just I mean different thing. It follows like a different algo for like image prediction.
See, so you are not able to understand this classification and the regression one, the difference between these two.
Yeah.
See, in the regression, my output can be anything, right? For example, the price of the house, it can be anything, right? Based on my training, if I give some new data, then it will be able to tell me my price for that data, right? That can be a regular number, 50, 100, 200, 300, 400. It's not restricted to a class of data, right? But if I train my model in such a way, and my aim is that my final outcome should be yes or no, or maybe some multi-class, it should be able to categorize my clothing, whether it's a pant or a shirt or a trouser or a hat or whatever. So I will define those my categories and I will train my model accordingly. Okay. Then my final output can be only out of those categories which I have defined. Okay, maybe in the next class I will give you I will do it for you guys. Okay, then it will be making more sense. See, let's say I need to train a system so that it can tell me whether my email is a spam email or not a spam email, right? So my target, my final outcome can only be two, right? Either it's a spam or it's not a spam, right? There is no third option.
Okay.
Okay, there are just two categories, two classes of my output.
Okay.
This is called classification problems. Either looking at the X-ray, either the patient is suffering from cancer or not cancer, right? Whether
Okay.
it's a fraud or not a fraud. Multiple categories, like if I'm sending an image, it will tell whether it's a dog or a cat or maybe horse, right? Only three possible outcomes will be there. Okay. So this is called supervised classification problems. Okay. If I have newspaper articles and I want to segregate them into three categories, so I will train my model in such a way, when I pass a newspaper article, it will say this is a financial news, this is related to the international, I mean politics, and this is sports. That's it. Okay. So my categories are predefined. When I talk about unsupervised machine learning,
So
what will
basically, because I'm training with the data for just these three categories, that's why I only have these three categories.
exactly,
I can have 5,
exactly.
10, 20,000, whatever. Okay.
Yes.
And when I'm doing regression, I'm basically trying to predict an outcome. For example, how much sales will I have, or like the example that
Right.
you've given, right?
Yes.
Like how much sales will I have, or what is the final outcome of this particular, if this data falls in like this, based on the past data, how or what is the predictive analysis of that?
Correct.
And binary classification is just like whether this is a cat or a dog,
Just
or
two
a whale,
classes are
for
there.
example. Yeah. Whereas multiple classifications can be which type of cat it is, because cats might be
Exactly.
thousands of types. Okay.
Definitely. Yeah. What type of penguin it is based on, its features, like what is the size of the nose, or maybe its wings, or height, or weight, and things like that. Okay.
Surrender, what
Mm.
on the overall summary,
Mm-hmm.
like it's a model we need to build according to aim of our last output. Suppose my output is like something straightforward. Suppose
Mm-hmm.
I need them like you told, like yes or no. It's a
Mm-hmm.
cat, dog,
Mm-hmm.
just a dog. If we ask any more question about the cat, what is the color, what is the height, what is the
Mm-hmm.
weight, like this type of analysis on our data, like we have to some deep understanding and deep diplomatic answers or some calculation basis things,
Mm-hmm.
then we can train our model like same perspective. Is it
Mm.
correct?
Yeah, so I see this is completely different from the way you are asking, right? For your task, we have to use large language models, which are trained on, different kind of data. These are very specific, task specific, models. In the machine learning, we have our target already decided, okay, and we, prepare our data according to that. It will not be able to tell you where these penguins are found and all those things. Getting? I prepare my data, I train my model in such a way, keeping what is my aim actually. Whether I need to find whether the patient is suffering from cancer or not, whether my email is spam or not,
Mm.
what will be my sales for the next year. That's it. Nothing like why my sales have been reduced. It will not be able to answer you. Large language models can be able to answer you that. So they are, that's why LLMs are more popular and more famous these days, because they are multitasking. They can do a lot of things. Okay.
Yeah, got it.
So when I talk about unsupervised machine learning, what is happening is here my data is labeled, right? I am telling it that this email content, the content of this email, this is an example of spam. This email is a not a spam, right? This X-ray has a cancer. This X-ray has also a cancer, but this X-ray is not having a cancer. So I'm labeling my data, right? I'm telling it upfront, uh, for these number of rooms, my uh, cost of my house is so and so, right? That means my data is labeled. I'm telling it the output upfront and training it, right? But in case of unsupervised learning, we are actually not labeling our data. Okay, we leave it to the machine learning model to create its own, it has to create some, for example, clustering. What will happen, I will feed some data, okay, some which is unlabeled, about the different type of flowers. As an output, it will tell me, what I can see is, with the given input data, I can see there are basically three type of flowers basically, and that can be maybe on the size of sepals, petals, their colors, whatever attribute we have given in our input data. It will try to see, it will club all those things which are similar in the features into one group, the two into other groups, and three into other groups. So it will create those groups automatically, and we don't know how many groups it is going to create, right? So this is called unsupervised machine learning, where we are not telling the machine model explicitly what output we are looking at. Based on some algorithm, some distance algorithms, it will perform actually. Okay, it will see the distance of the features of this flower from this flower from this flower. So it will see, okay, these flowers have some similar characteristics, so it will group them into one category. And these two flowers had attributes very similar to each other, so it has clubbed them into another category, and this into the third category. Okay, separate plants into groups based on the common characteristics. So this
So,
is
so,
just
so Surinder, in today's scenario for generative AI, we are mostly use unsupervised machine learning, like
yeah. So
testing and all.
generative AI is actually those models which we use in generative AI, the LLMs. They are trained on supervised machine learning,
Okay.
right? Okay, so this is the basic idea actually. So these subjects and all are actually so vast, and I actually need to show you how the training happens, then only you will be able to understand. But this is just to give you some brief idea about all these things. Okay,
Yeah,
so
Surendra,
let's say, yeah, I mean, let me give you.
sorry, I mean, because we are like in theory, maybe, and we are starting, we are
Mhm,
having like
mhm,
more
mhm.
thoughts.
Yeah.
So just one thing. So like you told, like we will be drawing a model, I mean, or like what do you call empirical form out of whatever the data we fed. Say like if I want to give more priority to one particular parameter, say like
Mhm,
location, I want to give like more highest priority to that. Can we
mhm.
have the flexibility in the model? Like you like take this as first priority even though the rest are like having like less thing or only it's like whatever it draws that model we can't customize it.
See, I mean, it's not about to give more priority to a particular model. What the algorithm will do is it will itself calculate by changing the value of that attribute whether the cost of the house is increasing or decreasing, whether it's impacting the cost or not. So it will decide by itself, and then only it will decide the amplitude, or the fraction of weightage it will give to that particular feature.
Yeah,
Are you?
I mean
Hmm.
I know
We
what you
can
tell,
change
but
the
if I
class, right,
want to give,
Surendra? Whatever the final output required, let's say in our case, instead of
Hmm.
price,
Hmm.
we can change some other class if we require. Might be that help for Revant.
no, I'm
Hmm.
telling is like say right now this price is like this. Okay, I
Hmm.
see like the suddenly there is a behavior change where like this year the people have started increasing the cost due to like I mean increasing the raw materials or increasing the land price. But
Hmm.
whatever the model we have drawn, that is based on the historical data. Okay,
Hmm.
but that model is not fitting with the real, I mean, real world expectations as of now. So if I want to increase the weightage of any particular parameters with the exist within the existing model, can
Hmm.
I do that?
No, I don't think you can do that. Okay.
Okay.
So the model will itself calculate its own rules, right? That will be on the basis of the data which we give it,
So that's
right?
why we have RAG, correct, Surinder? If we want to emphasize something especially over the model.
I mean, RAG is a little bit different thing. So you should not, confuse with RAG with all these models. RAG is something else, okay, which works with the large language models. Here we are talking about traditional machine learning models like logistic regressions, or like random forest, and all those models which we use for a specific task. So don't confuse it with the RAG. Okay.
So logically, what I understand is what
Mm-hmm.
you have to do, the scenario what Revant explained. If that is
Mm-hmm.
the things happening,
Mm-hmm.
you're gonna feed that data back again. So it is
Exactly. You
gonna
have
go
to,
back and
yeah.
yeah, it's gonna recalculate and bring you back to the updated
It will
output.
Exactly. So
exactly. It
this
will
is an
make its own rules basically
this
based
is
on the data that you're feeding in.
so this is an example of model drift basically. Your model is getting drifted because it is not it is not able to catch that COVID is going on, right? If COVID has happened, then your model will not be able to tell you the accurate, I mean, what will be the sales, what will be the price, because it has drastically reduced because of some other factor which your model has not taken into account. Your model drifting will take place. In that case, you have to take your data again and you have to retrain your model, and then it will be able to tell you, right? So that's what it happened actually. Lot of machine learning models were not behaving properly because of sudden rise in the cases, and I mean, because of this COVID, right? So that was the big problem actually in 2019 and 20. Okay, so that's why these days these LLMs are more popular, because you don't need a lot of effort to train. They are already trained with a vast amount of data, and then you can do multitasking with these models basically.
So sorry, so
Mm-hmm,
for this one concern,
mm-hmm.
for example, it's a large language model like Llama or ChatGPT. How frequently trained? If we talk about, there is any interval like 2 months,
No,
6 months, or 1 year?
no. They are not trained again and again. They have their own cutoff date. Okay, for example, for one model which is there in the market in 2023 is its cutoff date. That means its training is complete. By that, whatever training they had to do, they have done, and the model does not know anything about the incidents or events which happened after that particular cutoff date. Okay, so that's where we can use different tools or different
So,
APIs. We can integrate it with some external APIs which has the current knowledge basically.
so that's where your next versions of these ChatGPT or Copilot, these all things come in, right?
Correct. So what you will have is you will have some plugins basically. You have to use some tools. Okay, so when you're calling your large language model, you can associate some tools which will basically talk to some other APIs, like let's say some Google API. Okay, so it will go to the Google and it will try to find out the latest information. If your US has a new president, your LLM may not know because it's not being trained on that data, right? It had some cutoff knowledge, cutoff date, right? So what it will do is it will use some tool to fetch some latest information, maybe from Google or from some other API. Okay, so that's what it is called, RAG, retrieval augmented generation. We are augmenting our prompt and question with some external knowledge basically. That can come from vector database, that can come from some APIs or from any other source.
So there is again one confusion. You are
Mhm.
saying some using some tools. So some tool is like agentic, correct? Agent. And
Yes, yes.
how it is different? How you differentiate the RAG with some tools? Because what I understood, RAG is like we have some R data additional,
Mhm.
and where we can create that like a template and our question and context. But in
Mhm.
case of tool, we are using some AI agent where we have the RAG as well as some tools and this large language model like this.
See, these tools can be anything. Even if you write a Python program, that can also act as a tool,
Correct, correct.
basically, right?
Mm-hmm.
So if you want some structured output, you can use some tool, right? That this class will be invoked once you want, something, some customized thing, right? So these tools can be any weather API. If you want to fetch some data from the weather API, you can use that particular tool to get the data. RAG is something, I mean, see, this is one of the category of RAG because we are augmenting our question with some external, external, I mean, knowledge, right? Similarly, what happens in the RAG also, whatever the data of our company data, whatever policies we have, we vectorize it and we store it in a vector database. And if since our large language model does not know anything about our company, so what we do is first my question goes to my vector database, it will pull the relevant context and then it will send it to the large language model so that it knows, okay, for this company this is the promotion policy, this is the leave policy, and then it can finally create the final answer. Okay, so we will cover all those things, don't worry. I think we are going here and there. Does that clear your doubts, guys?
Yes, sir.
Yeah, to an extent, yes.
Can we take 2 or 3 minutes break, guys?
Yeah, let's do that, please. Thank you.
Yeah, let's take a 5 minutes break. Okay, we will come back at 10:22. Thanks.
I think you are on mute.
Yeah, yeah. Surendra, you are not audible actually.
Yeah.
Can you hear me now?
Yes.
Okay,
Yes, yes.
great. Okay, so what we have covered, I think these things will be clear once I will show you some real data and once I will train some model, then I think you will be clear about all these things. So this is model training and evaluation. So what we usually do is whatever data we get, we basically create two parts of it. Okay. And then with the one part, we actually train our model. And once we think that, okay, the model has been trained, what we will do is we will test it on our data, which the model has not seen. Okay. Because sometimes what happens if you train a model too much, it will overfit this data. It will be basically by hurting these different values. Okay. So in order to avoid that, in order to test whether our model has been overfitted or underfitted, we keep some data which once the model is trained, we try to do the predictions. And if our predictions are coming right, that means we have trained it in a correct way. Again, this is a little bit complex thing. You may not understand at the first go, but this is the idea basically. Okay. We have the data, we make the two part of it. One is the training data, other is the validation data. We train with this train data, we create our model, we train it, and then we test our model on this data which the model has not seen earlier, and we see whether the predictions are right or not, and then we evaluate our model. Okay, there are again a lot of matrices to evaluate the model, and they also vary whether the machine learning was for regression or for the classification. So evaluation matrix will also change according to the aim of the model. Okay. Again, deep neural networks, as I said, this is also machine learning, but the way is a bit different. Neurons fire in response to the electrochemical stimuli. Okay. So whenever we hear anything, we see anything, some neurons are triggered basically. So keeping that thing in the mind, we have this is called artificial neural network. We create these neurons and these are weights basically. Each neuron will have its own weight. And what we will try to do is we will optimize or we change those weights in such a way that our model can do the right prediction. Each neuron is a function that operates on an input X and weight Y. The function is wrapped in an activation function that determines whether to pass the output on or not. So this is a little bit complex. In the next class, I will show you in action. Then I think it will be more easy. So again, in case of neural networks, what we do is we create the layers basically. Okay, so these are different layers of neurons. This is my input layer, this is my output layer, and these are called as the hidden layers. Okay, each neuron, so they are called neurons basically. Okay, each neuron is connected to the other neuron of the next layer. Okay, like that. And each of these has some weights basically, na? W12, W1, W11, W12, W13. So when we train the neural network, our aim is to optimize or change these weights in such a way that our all the predictions goes well. Okay, so when we give it to it the penguin data, maybe the length of its uh, hands or legs or weight or anything like that, when we give lot of data, in the end it will be able to tell what kind of penguin it is. Is it a category 0, category 1, or category 2? Okay, this is the output layer which will give the probability of this image. Once I train my model, I will give an image of a penguin, and I would like to know which category does it belongs. So in an output, it will tell me the probability of this penguin input picture of being in the zeroth category is 0.2, second is 0.7, third is 0.1. Then we can say, since this has the maximum probability, this penguin image belongs to my second category. Okay, so this is a way to, visualize it. Okay. And okay, then we will come to generative AI. Okay, we have seen little bit what is AI. We have seen what is machine learning, what is neural networks, and when we increase the number of those hidden layers, it becomes deep neural networks. And now we are talking about generative AI. Okay, so we can see, right, this generative AI is on a boom for the last 3-4 years. So what is that trigger point actually, which you think has led to this revolution? Okay, the availability of the data is one of the reasons why we can see, right, these days everything is digitalized. There is a lot of data which is there, right? So availability of data is one factor, and availability of scalable compute capacity, right? This is also one of the factors which has led to this revolution. Right now we have, if I need to train a model, what I need to do is I need to go to my AWS. I have to choose the right machine, and I should have some data. The availability of data is there, right? I have the data. If for the compute power, I need not to buy anything. I can just go to any cloud provider, and I can spin up my virtual machine of my desired compute capacity. And then the machine learning algorithm and the innovation in the machine learning innovation has also led to this revolution. So these three factors, when came together, then the applications or models like large language models, or the chat GPT, came into the world. Okay, so this is just to give you the feeling why whatever GPT models which we are looking today, why they were not there maybe before 20 years or maybe before 30 years. Because at that point of time, we were not having such a large compute power, such large amount of data, and those some machine learning architectures were not there at that point of time. So now today we have all these things, and that is why we can see the models like GPT-4o, Gemini 1.5, Anthropic models, Llama models are there. So these are the important factors which has led to all these things. Okay, I think this is clear. So yeah, so what is generative AI? This again slide I have taken from Amazon. So the content is actually taken from different sources. Some of it I have written, some of it has been taken from Microsoft, some has been taken from AWS. So this is from AWS, I think. What is generative AI? It creates new content and ideas, including conversations, stories, images, videos, and music. So that's the beauty of generative AI. When we ask ChatGPT to create, to write something on Republic Day, let's say I need to give a speech in my school or in my office on Republic Day. Can you create one speech? Then it will be able to generate those things, right? If I say I need to create an image of a dog having hat on top of it, it will create an image which we have not seen in our past, right? It will create something new for you, right? If I say create one video for me, right, then it can generate the video also. So that's how it is different from uh, other things. It can create and it can generate new content. It can generate new audio also, new video also, anything it can do. So that is why the applications of generative AI are across all the domains. Okay, in the music industry also, and in the film industry also. For the movies which we need to hire the places, we have to book the places, we have to contact to the actors, and then we are doing the shooting and all. Right now these days we can create videos without all those things in just few minutes. By writing a good prompt, we can generate more efficient videos. Okay, I have to do advertise and all those things. What I can do is I can create images, create pamphlets, and I can do a lot of creative things just by writing a single prompt. So the question is again, why these models like large language models are different from the models like the machine learning models or the deep learning models which we just talked about. So earlier, the traditional ML models were, we have to take some data, some label data, and then we were training some machine learning models, and then we were able to perform some task. Okay, so what we used to do is for each and every individual task, we need to train the model specifically. If I need to create a chatbot, I have to train it in that way. If I need to do some entity recognition or some information extraction, let's say I put some one page, some 10 lines of data to my model, and I ask it that you should be list all the places which are mentioned in this particular article or the name of the person. So what it will do is it will extract those information. That is called information extraction. If I put 10 pages of data and I say summarize this data, or maybe if I put transcript uh, of my meeting and say summarize this meeting into one page, it will be able to summarize. So earlier what was happening is based on my task, based on my requirement, I was training a particular model. Okay, and that was useful only in doing that particular task. Now with this kind of large language and foundation models, we are able to do all these tasks with just one model which is being trained. Okay, so the GPT models can do text generation. In the chat GPT, if you say write an article, it will write an article. If you say summarize this thing for me, it will summarize you. Just give it the transcript of your meeting, it will be able to summarize. It will say these are the action items, these are the people who were present in the meeting. It will create that summarize. If you need to extract some information, it will extract. If you want to do question answering, it is doing chatbot and all those things. Yeah, please. Revant, you have some question?
So basically, is it like they have clubbed all the libraries into one single library in the foundation model?
No, it's not like that. It's like that they have trained the model in such a way that it can do multiple things. It can see the bottom line is just like we as a person, when we take birth, we see people talking around us. And so gradually what we do, we learn lot of things. We learn those sentences, right? And then after 1 or 2 or 3 years, we are able to understand what someone is saying, and after a year we are also able to speak, right? Similarly, when we train this foundation model in such a way with the vast amount of data, they are actually able to create that intelligence. They develop that intelligence that they can understand your question and your task, and it can actually do the task for you. Okay, earlier we were very specific. We were telling it that this is what you need to do, right? Now the training and all is so vast, and so see, this training was very small actually. The training which on which these LLMs are trained, they are like so big. They are like for months actually. Okay, the models are so big that you cannot even deploy those models on your machine now. That terabytes and petabytes of data, right, from all over the internet, from the Wikipedia, from all those things, they are trained. That's why they become so intelligent that they can do multiple tasks. Basically, whatever instruction we give it, we say do the text generation or create one article on this topic, so they are able to understand your language on your task, and then they can give you the output, which was not the case earlier, because they were not trained sufficiently. They were trained only for a particular task. Now we have these foundation models which can do multiple things together. Okay, it has developed that intelligence just like us. If you ask me, summarize these 10 pages into 10 pages, I can do it, right? Because whatever training has been done with me in my past years, whatever I have learned, I can do it, right? I should not be trained to say, if I see a car in front of me, I'm not trained that this is a car, right? I can automatically say this is a car, this is a tiger, right? Like that, these foundation models are trained with so vast amount of data that they are able to do multiple tasks. And you will be surprised to know the electricity which these models consume. They are like very huge electricity. These uh, Amazons and these OpenAIs, they are actually buying nuclear power plants in the USA in order to create that much amount of power which is required to train these models. So the amount of electricity which they consume is equivalent to, a small town which it consumes in duration of 2 months. Are you getting? Such huge compute, such a huge electric power is required to train these models. It's not a uh, small, it's not a small task training
Uh,
these models. Only specific, providers are able to do this. Yeah, tell me.
So how like the process they would have done, Surendra? So like there'll be numerous things like identifying animals, everything. So
Hmm.
how they have trained? Is it like they have asked you to go through all the complete internet and train, or like say like there
Yes.
will be like lakhs of animals? How they will train like this animal is this each?
So they
Do you
have
have
been
like?
trained on all those data actually.
Oh, okay,
Yeah,
okay.
that's what I'm saying. They are trained on such a huge data from the internet, and first they clean the data and then they train train their models, right? So whatever
So
your chat GPT can answer, it has been trained on that. It's not that it is not trained on. If it is able to tell you about US civilization or Indian civilizations or Harappa Sanskriti also, it is only because it has been trained on that particular thing. Yeah.
think about this, like there are programs that can identify if a person has used artificial intelligence, basically AI or ChatGPT or like any OpenAI tool or anything to
Mm-hmm.
generate their work or something, right? Like students if they do essays that way.
Mm-hmm.
There are models or there are softwares that recognize that this is AI generated content versus person written. How would that be trained? Because ultimately there are like 8 billion people on earth. Everybody can write the same thing differently.
Mm-hmm.
How do they see whether how is this different from the machine generated versus like human generated kind of thing? How
I
would you
mean,
train that kind of a thing?
again, it depends, right? What kind of data it has been trained on. So maybe when you say whether it's a or LLM generated text or human generated, maybe it is looking at the patterns, right? The way we write the things, the way these machines actually generate the text. That is, they are able to find some difference in that, right? They have that
But
intelligence. Yeah.
we are the ones who are training these
Yeah,
like or
that's why there is a fear that these machines, if they are already, there are a lot of tasks where they are doing it better than human beings. That's why the people are so worried, and they are also fear of that what will happen if we keep on moving in this path. Maybe the machines will control us, not we controlling machines. So that's definitely is a concern, right?
So
Because
only thing, Anand,
Mhm.
only thing is missing here is emotion, which machine
Emotion.
can't do it.
Hmm.
Emotion. So
I mean,
that's
yet.
what, so that's what when you're talking about essay and all, that's what they want to see the human emotion and touch reflecting there in order to identify.
no. See, even if you say your chat GPT that you generate some text which is more like, which looks like human has written, then it will be able to write in that sense also. You have to give it a right prompt. You have to give it that persona that you are a student of a class 10 now, or you are a student of a class 5 now, write a essay on my best friend. Then it will be able to create that kind of text also. I'm not sure which software can actually tell whether it's a LLM generated content or not, but
If you Google on that, like there are
mm,
quite a few. Um,
maybe.
I am missing the word right now, but
Mm-hmm.
I was using it to check some of the things. So yeah,
But
um,
these models are
I think
really
Oxford. Yeah,
these
no, go
models
ahead.
are actually so strong and so powerful that I'm really impressed by this technology, right? So even if you say So the content it will generate, it will definitely be different from the content if I simply say create an essay on my best friend, right? So these prompts actually does matter. If you say write a poem on my best friend, then it will be able to write the poem also. Ria is a kind, helpful, and always makes me laugh. She has a big smile. Okay, so it will try to use some words which will try to mimic a student of class 3. That's what I'm saying. So it depends basically how you're writing the prompt, and then I think you can over smart.
So
Okay.
this information is coming from the database, Surendra, correct? Like
Mm, no, no.
already the model
Uh-huh.
is already trained, and
Hmm.
they used
Hmm.
to store the information in
Yes,
database.
yes, yes.
Mm. So as you
So,
said, like the maintenance for this database, like that contain huge data.
mm-hmm.
So as you said, it require more electricity power. So in
Mm-hmm.
future, in disaster, then like maybe all these things will get shut if we are unable to provide the electricity or whatever
No,
they require.
electricity is required
Mm.
only when they are trained
Mm.
basically. At the time of
Okay.
training, it requires huge power, right? Because what
Mm-hmm.
we do is when we say a model is 500 billion, okay, that means it has 500 billion parameters. Parameters are nothing but we were talking about attributes, right? We were talking about attributes like the number of rooms, the size of the room. They were attributes. Similarly, when I say parameters, those are basically weights which will have some value of each for each, I mean, neuron. So those many values will be stored in your space, and then it will be calculated. Your loss will be calculated on those weights. So lot of calculations actually happens when you train a model, right? You give some data, then it will create some output, and then it will with it will try to create some loss function, that how away is my model from the actual truth, right? I will compare y with the my actual y with my expected y, and I will create the difference. So and then it will go back, and then it will change those weights, okay, to reduce the error. So this type of processing basically takes lot of power and lot of electricity, okay, lot of
Mm-hmm.
compute, and as well as all these resources. So that is more costly. Once it is has been trained, or once its weights value has been decided, then running it does not take that much resources, but training definitely does more, because it has to
Mm-hmm.
change those weights, and it has to put those weights in cache, and then do some calculations. Okay,
Okay.
let's be back on our PPT, otherwise we won't be able to finish it.
Yeah,
Okay, so
Surendra Udankar,
hmm,
this chat GPT is also an generative AI tool, right?
hmm, hmm,
So if you ask a question,
hmm.
uh, I know it. I mean, it comes up with data, but where does it get the data and how does it get the data from? Say, if it is picking from Wiki, is it an API call or is
Hmm.
it taking from any other source? Is it
No,
an
no.
API? Okay.
On so it is not storing anything. As I said, when you train a model, its weights will get changed basically.
Okay.
Okay, weights like when I say x plus 2y, y is equal to x plus 3x square. So these 3 and x square, all these are actually weights. So you can think of weights as, let's say I have a radio. Okay, so I have couple of buttons, right, which will help me to tune my station. Earlier days, right, we have those transistors. So what I do is I move one knob in the clockwise, other in the anti-clockwise. So after some time, I will see, okay, my transistor can catch the signals. Similarly, in the neural networks, we tune those weights in such a way that they become optimum, and it will be able to understand our text. Okay, so only thing it is storing is the weights. Okay, weights of the model. W1, W2, W3, W1X plus W2Y plus W3Z. These weights are the values basically. It is not going to any database or something like that. When I talk about a neural network or a model, it means that those number of layers and the weights corresponding and their values basically. I will show you in the next class. Actually, that will make more sense when I train a model in front of you. Then I think it will
Okay.
you will be able to
Okay. Yeah.
relate.
Yeah. Thanks.
Okay, so these in my this slide I talked about machine learning innovation. So what happened was in year 2017, Google came with a paper which was attention is all you need. Okay, so there is a research paper from Google. So this paper, which is by Ashish Vaswani, Google Brain. So this was team from Google Research. Okay, so they came out with this research paper and they said they talked about this transformer architecture. Okay, so the picture in my slide is exactly this one. So they talked about some architecture which was actually helped us to accomplish the things very easily. So what this is actually, it has two parts basically. One is the encoder part and other is the decoder part. Okay, so this is my architecture on which all of my anthropic models or Gemini models or whatever models you are hearing as of today, all are based on transformer. Okay, and this paper was released in 2017. So what it talked about, it has two parts actually, encoding and encoder and decoder. Okay, so the data which we are talking about, we actually pass our input data to this encoder part and my output is generated from this decoder part. Okay, so encoder converts input sequence to hidden states of the text, positioning it in a semantic field. Decoder generates output sequence from the hidden states. So what it has, it has basically multiple layers of attention. Attention is what? When I have a sentence like why did the chicken cross the road? Okay, so this transformer model was good enough to understand the sentence in a way that it was able to understand the meaning of the sentence better than any other model which were there before 2017. And it was because of the weights attention mechanism. What that attention mechanism does is when I input or give my sentence, okay, let's say this is my sentence. Okay, so what it will do is for the word why, it will try to calculate what is the significance of why with respect to the other words in the sentence. Okay, what is the significance of why with respect to did the chicken cross the things like that, and it will store that weight uh, in some hidden states. Okay, so all in all, this encoder part help this architecture to understand the intent and the meaning of the input sentence. It will store and it will try to find out the meaning or the relevance of each word with respect to the other words in the sentence. That's why the chat GPT don't get confused with, earlier what was happening is there were a lot of challenges with natural language. Whatever models which we had, they were basically not able to they were not able to calculate the actual sense of the sentence. Today, even if I make a mistake in my sentence, maybe that's not grammatically correct, but still your GPT model will be able to understand the intent only because it is using the attention mechanism. Okay, with the help of attention mechanism, it is able to make out the meaning, the exact meaning or the intent of the user instruction. And in the decoder part, what we are doing is we are generating the output. For example, if I give only the sentence, why did the chicken cross? It will be able to tell me the road because the road is the most probable word as per the model. Okay, so this is how it works. It basically generates word by word output. It predicts the next token. When you give why, so it say, okay, after why you have written did, after did you have written the chicken. So based on these words, what it will do is it will try to calculate the next most probable word. Okay, and then it will tell you the road as an output. Okay, so this is an high level overview. Maybe once we develop our understanding more and more, maybe we can revisit this architecture because right now you don't know what is embeddings and what is positional encoding. So once we develop some meaning in after a few lectures, I will revisit this transformers architecture. Okay, so don't get worried by looking at this complex diagram. Okay, only thing you need to know is there is something called the transformer architecture, which has some attention mechanism, which helped the models to understand the meaning of sentences more efficiently than anything else we were using till date. There were things like RNNs, recurrent neural networks, LSTMs, GRUs. So those were the models which were able to understand the meaning of the sentences, but not 100%. There were some shortcomings. If I give maybe 5, 6 lines, then once it read the fifth line, it will forget what does my first line means, right? So this was that technology shift which helped the uh, you know uh, uh, whatever shortcomings which were there earlier, it overcome all those shortcomings, and there were more, I mean, progress which was made in this field after the transformer architecture because of its self attention. So you just know this is story, that's it. You need not to go inside what is feed forward and what is multi-head attention, what is position encoding. Maybe I will revisit, but at this point I don't think if I explain all these things, it will make any sense. You will get confused. Okay, is it fine, guys? You can read this paper maybe. If it looks very interesting to you, go on the Google and just search this transformers attention is all you need paper. Okay.
Yeah, please go ahead.
Yeah, so there is something called as the inference. Okay, so this is my language model, and when I give it the instruction, there will be some output. So this is the entire process is called inference. Prompt is what the my input text to the model, and what is completion, the output text generated by the model. Okay, and what is inference? The process of generating a completion from a prompt using a model. So this is a term actually which we will be using even now and then. So you should know this term. What does the inference means? When I say I will inference GPT-4o, that means the mechanism of giving some prompt and getting the completion out of it is called inference. Okay. So just include it because this is important term. You should know what is inference. And what is, again, what is large language model? As I said, large language models are trained on a large corpus of data for weeks and months, predicts the next token. How it is trained? It will try to predict the next token. It is trained in such a way that what I will do is when I train the data, let's say on this line, I will mask this particular word and it will ask the model to predict this particular word. What should be the correct word? Then it will predict something. Maybe it will say, then uh, pen process until the completion. Then what it will do is it will see whether the whatever the large language model produce the output like pen, whether that was correct or not. So that was incorrect. So that the loss will be huge. So it will go back and it will try again. So it will try and try and try until it is able to predict the right word. Okay. At that point of time, my loss will be minimum. So this is how they are trained. They are trained for the to predict the next token. What should be the next token to complete a sentence? So they are built using the transformer architecture. Transformer outputs a probability distribution over the vocabulary given to the input sequence. Okay. So what it gives it, as I said, in case of neural net, in that slide, right, where it had to find the penguin, the class of penguin. So what it will do is it will give you the probability. The probability of the input image for the first category of penguin is 0.2. Second was 0.7. Similarly, next probable word is calculated in terms of the probability. The word which has highest chance to come in the next token will have the highest probability.
So, Surinder, all the LLM models are built over the transformer model?
Yes, yes.
Okay.
Some are having encoder part, some make use of decoder part, and some are based on encoder decoder. So that depends on their use case. Okay.
Okay.
So they use lot of compute power and the params, the memory of the large language model, right? In our brain, we have some memory, right? Similarly, the parameters which we say 4 million parameter model, that means it has just 4 million weights. If you say 40 million parameters, then it has 40 million parameters to store the weights. The more the parameters, more the strong the model will be. Okay, on more data it has been trained, or it's like our memory, right? The more the memory we have, the more data we learn, larger it will be basically. Okay, so it's 11 o'clock. Do you want to you guys want to continue, or we should stop here? So I have a couple of slides like how LLM next token words. These are some configurations.
Yeah, let's continue, please. Let's get this over with so that we can start with the next one next week, whatever you have planned.
Okay. All right. So how LLM selects the next token? Okay. As I said, these large language models work in the sense that it generates the next probable token. Even when I'm saying write an essay on India, when it writes basically, when it says India is a great country or India is a country in the Asia continent, what it is doing is it is generating tokens one by one. So what it is doing, when first it generate the first token, and then the next token, then the third token, then the next probable word. Like that, it is creating those sentences word by word basically. Okay, so it uses a softmax function to output a probability distribution of each word in a vocabulary. Vocabulary means when I train my models, let's say I had just trained my model with 100 words. Just take an example. So what it will do is it will create one dictionary of those 100 words. And now, when it has to create some output of the next, probable token out of those 100 words which it has in the dictionary, it will create one probability. Okay, let's say these are the words. Okay, these are those 100 words. So one word will have probability of 0.2, the other will have 0.1, the other word will have 0.05, like that. If I sum all those probabilities, it will come out to the 1. Okay, so all the dictionary words, whenever it has to predict the next token, the probability of all the possible word, it knows that probability will be calculated, and the word which has the highest probability, that will come as an output. Okay, so this is what the softmax function means basically. This is a bit technical, but still, I thought maybe it's worth telling you. So softmax is a function. Okay, when the output is generated, it basically generates the entire dictionary, whatever words it has learned, along with the its probability as a candidate for the next token, 0.2, 0.1, 0.05, and so on and so forth. If you sum, it will come out to the 1. For example, if my sentence is, why did the chicken cross the... Okay, so what it will do is it will try to finish this sentence. It will predict the next sentence. It will see, okay, road has the 0.2 probability, river has the 0.1, house has the point. So what it will do is it will see, okay, the road is the maximum. It has the maximum probability. So it will give road as an output. So it will complete the sentence as, why did the chicken cross the road? Highest probability word is road, is the most likely next token. Okay, so this is just to give you an intuition how it internally works basically. Okay, these large language models, this is also called as the streaming. They stream word by word basically. Okay, but there are some configurations which we can do so that our output from the LLM is basically changed. For example, when I say the maximum tokens, I can restrict it to maybe like 200 tokens, or I can change my sample top K value, sample top P, temperature. So these are a couple of configurations which if I do, that will alter my output from the large language model. Okay. So if
What's
I
the
said,
sample top K, P, temperature? These are like just random things or specific?
I will explain. Yeah.
Okay, thanks.
So this is like the first one, which is maximum new tokens. So if I say that if I set this particular property, maximum new token equal to 100, what it will do is it will stop generating the tokens after 100 tokens. Okay. Maximum new tokens is 150, then it will generate those 150 tokens. It's if the maximum limit I put is 200. So this is basically this can be thought of, if I want to restrict the output from my large language model to reduce my cost. Okay, let's say I have created one LLM and I have publish it for the general public. I don't want them to use it like anything. Okay. So what I can do is I can put some restriction for every prompt. My LLM should be giving maximum 100 tokens as an output. So I can make a check on the total number of tokens which are being generated. Okay, so this is one of those settings we may not be using it very frequently. Only thing which we use is the temperature most of the time. Otherwise, I mean, this is just for your FYI kind of thing. So you can limit the maximum tokens being generated by setting this property. That's what the meaning is. Then there is something called as the greedy versus random sampling. As I said, when out of my softmax layer from my neural network, what it produces the probability of my most probable words. So when I set my configuration as greedy, what will happen is it will always select the word which has the highest probability, 0.2. The word or token with the highest probability is selected. Okay. And if I do it like random sampling, what it will do is it will select a token using a random weighted strategy across the probabilities of all the tokens. Here, there is a 20% chance that cake will be selected, but banana was actually selected. Okay.
And where we use the greedy and where we use the random one.
So these are actually some configurations. If mm,
Like basically, why would I choose random sampling?
hmm.
Like if I'm going to get the most predictive answer by getting at the greedy algorithm, why would I even use that random sampling?
See, if you use the greedy all the times, what will happen is your answer will be same, right? Let's say I want to uh, write a poem, and or maybe I am doing some creative thing, right? In that case, what I would like to do is I would use some different words, not like the most probable word should come all the time. Okay, in that case, I can choose this random weighted sampling. Okay.
Okay. Yeah.
Actually, these are not, I mean, even I have not used, these are some theoretical concepts which are somehow there, but they are not, only thing which we use is, I mean, top K sampling, top P sampling. There are options, but what we generally do is we just use the temperature setting most of the time. Even when we write some API code, we set the temperature. Okay, so low temperature means what will happen is strongly peaked probability. So these are technical things. What happens when you lower your temperature or when you increase your temperature setting. Okay, or maybe let me see if I can show you. Page not found, playground. Okay, so this is what I'm talking about. So this is a playground where you can actually experiment your output with different settings. Okay, so you can see the model. I can choose the models which are available. For example, right now GPT-4o. Then I have this response text. This is the temperature. Okay, so this vary from 0 to 2. Okay, some models have this temperature vary from 0 to 1 also. So what this temperature will do is, if I make the temperature as 0, then my answer will be very accurate, right? And it will be same all the time. Okay, whatever the text it will create, that will have the most predictable or the most probability words only. Let's say I am doing some fraud analysis, or maybe I'm using the models for some healthcare. Then I don't want to experiment. I don't want to it to create something creative, right? In that case, I will be using low temperature. When I do the temperature high, let's say 2, what it will do is it will create different type of responses. Okay, it will try to be very creative. Let's say I want to write a story, I want to write a poem. If I want to do such things, in that case I can increase my temperature so that every time the response is different. Okay, I have written some examples also. For example, when to use each setting. Okay, low temperature means the model is more confident in its top choices. The results are more deterministic. Okay, same results will be uh, shown to the user. What is the cons? The model is more likely to fall into infinite loop of tokens. The response are less creative and diverse. Okay, the responses will not be creative because each time it will give you same response. Let's say I want to build an application which will tell me the name of the restaurant, right? I say I want to open a food restaurant, can you suggest me some good names? At that time, instead of having the low temperature, what I want, my temperature should be high, so that it becomes creative and it will not tell me the most probable words again and again. Okay, if my temperature is high, the responses are more creative and diverse. The model is more likely to explore less likely completions or less likely tokens. Okay, it will also give you in the response the tokens which has low probability basically. Okay, the models may produce less predictable responses. When to use each setting, use a low temperature setting for applications that do not require creative generation, such as generating MySQL queries. So when I am generating SQL queries, I don't want my uh, application to be creative, right? It is giving different table names. So what I will do, I will keep my temperature low, so that it will precisely give me the accurate results which are not diverse, which are accurate basically. Okay? Use a high temperature setting that require more creative generation, such as generating copy of a landing page or a short story or things like that. Does that make sense?
Yeah, Surendra, can we have this session continue tomorrow? Because this first session, right?
Yeah,
We didn't prepare for what do you call buffer time actually. Say maybe tomorrow we'll prepare for buffer time and we can continue actually, Surendra, if you don't mind. This
Yeah.
first day, we have other plans actually planned accordingly. Yeah.
Okay, even I had the same thought. I don't want to give you a lot of things in the first session so that you are not able to digest all the things in just one go. Okay,
Oh,
so yeah,
would be the next session in the next weekend or tomorrow?
next weekend only.
Next
Tomorrow
weekend
is
only.
anyway we have the Republic Day,
Yeah,
right?
yeah. Sure, sure.
I have some
I agree.
actually some events in my
Sure, sure,
society.
sure.
All right then, guys, I will stop here. If you have any
Surendra,
question,
this recording is going to share, right?
yes, I will share this recording with you guys. Okay.
Okay.
So
And please share over the email, right? You will be sharing over the email, not
I
the
will
WhatsApp.
I will share the information in the group. Okay, in our WhatsApp group, I will share that information.
Okay.
Is it possible to send it over the email also?
Yes,
What we have? Okay.
yes, I will do that.
Okay.
Okay.
Thank you, Suren.
Yeah, thanks everyone. I know that it was a bit monotonous session because, but without having this fundamental knowledge, it will not be an easy journey. So bear with me. Just try to digest all these things. Just try to explore other videos also, if there were a couple of things which were not making sense. Okay. And then we will meet next week where I will cover the machine learning, and I will show you the actual model running on my machine. Okay. All right, guys. Then have a great weekend. Enjoy.
Thanks
Surendra,
a
one
lot,
query.
Surendra. Thank you.
Thank you, Surendra.
Thanks
Thank you all.
everyone.
Bye.
Bye bye. Bye.